Hi, in this video, I'm going to talk about the asynchronous framework, task framework developed by Dropbox. It is not an open source. They just created this internal framework and they just provided those informations in this article. So actually, I was trying to develop a job execution framework for one of my project, and I was searching for a lot of articles to get to know about the different ideas used by the internet community. So basically, if you want to develop any batch jobs, we can always use a framework called Spring Batch and Easy Batch and other things, other open source frameworks. But here, the main aim is to execute the task, and it's like asynchronous task, and then like monitor it, and then provide the task status informations to in other customers or other applications. So we want to develop such applications. So by using Spring Batch is not the right options, because we need more features. Like in addition to the execution part, we need to have a scheduler part. We need to have a monitoring part and everything. So while trying to find out a similar framework in internet, I found out this article. After reading this article, I got to know about a lot of informations, and thanks to the Dropbox team. And let's jump onto this architecture of this frameworks quickly, so that we can easily understand what I'm actually going to talk about. Let's go to the architectural diagram here. If you just look at this, the architecture diagram is of this asynchronous task frameworks is given below here. So here we have a front end. Front end is responsible for scheduling a particular task. Front end create a task entity in the database. So here they store all the task informations in a database. And if the customers, if wants to know about the task informations, then they can always query that informations from this database. So the first step is to create the task entity here. And then there is a component called a store consumer, which is periodically monitoring the database and all these entries. And if the task is available and it's ready to execute, then it will pull this task and then push this task to the appropriate Amazon SQS queues. So they just mentioned that they have priority based queues here, so we can have more than one queues here. So maybe they might be having high priority, medium priority, low priority queues. So based on the priority of this particular task, the store consumer is responsible for enqueuing the task into corresponding SKS queues. So once the task is pushed into the queue, then we have a worker machines. The worker machine consists of two main components: controller and executor. So executor is responsible for executing a particular task, and the controller is responsible for pulling these tasks from these queues. And then it will also update it will also notify the heartbeat and status controller to update the status informations. Actually, this task got pulled, and it's going to be executed. So it has to climb this particular task. So controller machine is responsible for controller's process is responsible for updating the status in this to this edge store database. So via this heartbeat status controller component. So once the task is available, the available executor tries to poll for the task. And once the task is available, then it's ready to execute. And then it has to once the task is done, then it has to notify the heartbeat and status controller. So its status controller update the status information in the HStore database here. So if some problem, if this executor is not available, because we already have this component is responsible for monitoring the executor. So if the executor is not available, then it will try to it's not going to bring up this executor. Instead, it's going to change the task status to enqueued or some other thing, so that the same task might be picked up by the store consumer in the next run. So in this way, they're just maintaining everything in a proper way here. So the flow will be like this: creating the task entity, and store consumer polls the task, and then push the task into the Amazon SQS queues, and the controller pull this particular task and update the database with the proper task status informations, and executor tries to get the next task from the controller, and it's execute it, and then update the start status task status informations in the database. This is the proper flow here. So yeah, this is a nice way of handling all the task execution, asynchronous task executions. After going through these things, I got a good idea about how to build a such framework, because this is not an open source, we can't use their approach. So we got a lot of good things from here. So yeah, that's it about this framework, and I will leave the this particular URL in my video descriptions. Please take a look at it, and if you have any questions, please leave your comments here, and also please check this article. It's a nice articles. If you want to develop any a task asynchronous task execution framework, and you can make use of this one. Thank you.